Welcome to the video, guys. This is Ripudaman in front of you, and today we are going to discuss about a particular topic, which is QUIC, which is a particular protocol which comes under the transport layer, which is the QUIC. That means it is faster than the other protocols. Yes, we're going to discuss about all the details about this particular protocol in this particular video. So this is QUIC, which comes under IP, Internet Protocol, and here is the UDP on which it is built, and this uses the UDP, and UDP uses the IP there, and it is faster, more efficient. Obviously, we're going to discuss how this is more efficient and better than TCP. Yes, we are also going to discuss about this particular video. Multi-stream connections and channels for transferring your data to the server, to the client. This particular protocol is being used by 31% of all the websites and servers around the globe, and it will take over, obviously, adaptive to network conditions, different network conditions, and we are going to discuss about that in this particular video too. So next up, what is particular this QUIC is, which is particularly developed by Google. Yes, and because they were also testing the Gmail's functionality with their own servers and computers, there comes the GUIC, modern network for protocol designed and faster communication and over the protocol. Why it is faster? Because it also saves the data and request also, which is being also carried out at the earlier stage also, and takes that particular, and also uses the UDP, which is a connectionless, and it do not initialize too much as per the TCP does, and this uses the UDP, as I told you, protocol providing for the lower latency and faster transmission. Then there is each stream in the each stream data flow that it comes around like this. Suppose this is a stream channels, different stream channels include like this. Here is the server, here is the client. It uses different stream channels, like 3 stream channels or 4 stream channels for transferring the data from the client to the server, so that all the data is transferred and received at the both ends simultaneously and parallelized also. In TCP, it is only one, and it do not parallelize that stuff and only sends single data at a single time and that particular pace. So this is how the TCP and the UDP works, and on which the QUIC is built. And this also enhances and independently works and avoiding the head of the line blocking issues, which also includes the transmission and improves the streamline structure of that particular protocol for transferring the data from one end to other and receiving from both ends too. We're also going to do the Wireshark also, and I'm going to show you all the details that's come across this particular streamline structure. And it also includes the TCL, the transmission control layer for that particular security layer, and encryption implementation by default because it comes under the UDP, as we discussed earlier, ensuring the integrity of the data. Obviously, all the data from left to right, the client to server and server to client, it should be maintained in a proper sequence, and it should be received from one end to other. Then it is a quick response. We are going to discuss that why it is quick and how it is quick. And it is being used by many browsers and servers like Firefox and Chrome and other too, across different multiple communication schemes also. Why it is essential, how it is essential in this particular internet. It is designed for minimum latency, offering faster connections, established and data transfer compared to other traditional protocols, because it is using the UDP connections, so that it is very fast as compared to the TCP, which acknowledges for each and every request and that particular reason, so that it is very fast than the TCP. And next we have the concurrent transmission, as I told you about the parallelism of the streams, as we have that also initializes and speed up the overall communication. Yes, it does. Each stream operates independently. Yes, each stream that I discussed earlier, as I can show you right here. Each stream that is works independently from server to client and client to server, so that it is fast. Next, we have here is efficient data transfer and multiple streams of, as I will discuss earlier, multiple streams transfer and concurrently over that particular reason. And standardization of this particular, so there are a lots of protocols. We use the TCP, the UDP, and this particular QUIC. As I told you earlier, the 31% of all the computers and websites and servers uses this particular, and TCP is 51% overall that particular, and H1 and H2 and H3 is also come across these particular activities and the protocols used. So it is scaling up and it will take over that particular so that it is fast and reliable according to the needs. It's the basis so that we are going to discuss how the flow manages. In the HTTP2, it includes the TSL, the security layer, and then the TCP includes this particular 3-step process. And in this is very slow as compared to the QUIC, because the initialization and all the sending request comes here and it initializes and establish the connection between the server and the client and acknowledges every time, single time, and waiting for the server to respond. And it take about 3 times of that particular QUIC, as I'm going to show you also the diagram later on. HTTP over the QUIC, it also encapsulates all the things like congestion control and loss recovery, as it is going to, in the loss recovery also, if a packet is not being received by the client or server, it is going to duplicate that particular packet and send it again, or the same time it is initially sent. So if the one packet is lost, the other can be used if it is important, then only. So that is how this is compared to the TCP, as we can see here. The authorization here included in this particular region, as we can see, and the 1.3 security layer is being used in this particular protocol. Next up, we have the QUIC operates at the transport layer as I discussed above, and which is based on the IP control similar to the TCP and UDP. UDP is connectionless and lightweight protocol, as I discussed earlier, because it is very fast due to this particular reason, allowing the QUC to operate reducedly over, so that I told you that TCP again check the acknowledge message and again send the request for hello client and hello server. So it checks too much as compared to the UDP, which is a connectionless. It do not batch any connection with the server and etc. And then build being on the UDP, it uses the flexibility and adaptability. Obviously, it is using the UDP and it will gain all the functionality of UDP plus its own functionality, which will help it into betterment of that particular reason that is at a faster protocol. Yes, it is involving the network conditions. Depending upon the network condition, it also affects that. If you are watching a YouTube video, that may affect if you change your network or not. That depends. Next up, we have this particular schematic diagram, which is similar to that we saw earlier, which includes the HTTP schematic diagram, which includes the if it is TLS. This is for the HTTP and as for the QUIC. As you can see here, TCP and QUIC, it uses the UDP protocol. Initially, the initial process are same as compared to the HTTP 2 and 3 particular, which includes the server push and the requesting and request that particular from request to server, client to server actually, sorry. And this particular stream multiplexing, which includes the multiple stream, and that particular reason, that matter of fact, is included in this particular QUIC. So this is particular for the security reasons. TLS is the security reason that particular authenticates and key negotiates. That means matches the key from server to client for the data to consume that particular there. So this was all reliable and congestion control as we discussed earlier. And this is the basically the difference between these particular protocols, the QUIC faster and TCP, and this particular table show you the comparison between the QUIC, TCP and HTTP. As you can see here, multiplexing and independent streams, not independence in this particular limited and head of the line blocking, because one stream at the one time, and HTTP2 improving the multiplexing compared to the HTTP1 obviously, and 3 is much faster, which is being used by the QUIC, and has the independent streams and transmission controls are also there, and the security breaches are less in compared to the QUIC, but there is, we will discuss it further in the video. Undergoing the standardization of, as we discussed, the standardization is also being held by the IEFTF, that is particular in this particular 3 comparisons. Now, as you can see here, this is how the TLS 1.2 and 1.3 and this particular QUIC that particular works. If this is the TCP and this is the QUIC, this is QUIC in a specific case. That is the TCP initializes the first request, the client hello and server SIN, then acknowledge, then sending the request, and then client hello, then server hello, then request, then response. That takes along 300 milliseconds, but in this particular is it is using the UDP, so it directly goes to the client hello and the server hello. And as you can see here, as I made this particular block diagram, first about the TCP, it sends the SYN and SYN acknowledge, then acknowledge sent from the client to the server for the acknowledgement, and the TCP hello and client is then sent. This is the initialization till now. Here is the request and response we receive from that particular server. This is the TCP. Here is the QUIC. It only uses the UDP because it's UDP. It is using the client hello directly and server hello, and then the request. One layer less than the TCP. Here is the particular condition where if there is an earlier connection between the client and the server, such of if I have 1 hour ago I searched this YouTube and it is also now I am searching the YouTube, it will take that particular cache data or that particular protocol which use some conditions to directly go for the request, not establishing the connection earlier. UDP is basically overall, if you tell UDP based 0RT, and then TLS 1.3 protocol, that means the security layer I discussed about, and this is enhanced flow control and loss security as we discussed earlier. And this is the example. If you are in your house and you are using your phone, you are connected to the Wi-Fi here, but if you switch and you came out of that particular range of the Wi-Fi and you switch to LTE, then your the destination port and the source port also different, IP changes, that particular changes. So but your YouTube video runs as perfect as it should be, because the QUIC particular protocol is being used in your phone that switches that connection, but a single port is there, a default port which is set to some value which is being fixed no matter what your IP changes, your video changes, no matter what, the connection is established there. Then the connection is established, and this is all that happens. And your if you're in your car, you switch the connection, and that works pretty well. Then we can discuss about the QUIC uses, which is the use in the Google Chrome, Firefoxes, and other also resources. And you watch the YouTube, as I go for the YouTube videos, Netflix and other streaming platforms, which also uses the GUIC, a mobile application which needs a real-time communication, which uses these particular protocols, and messaging, which needs such of a sockets and this particular protocol for work and real-time communications, for that the data should be transferred in the real-time systems. And IoT devices also, the real-time, all the real-time scenarios where you can get the data and receive from the server at real time, it will use the QUIC particular protocol, which is the best in this case too. Let's talk about the security threats, which is QUIC security threats. It includes the attacks, different attacks like the server caught the connection requests and malfunctioning, and packet structure can be modified. And but there is a TCL layer 3.2 we discussed about earlier, which is being applied, but there are some threats. There is always threat with the particular protocols. There can be traffic analysis and metadata, the important data which can analyze the information that is particular present in this side of the packets, that can be leaked through that. And denial of the service, which is related to the service outage, and packet amplifications, which can like modify or little enhance, amplify the impact of the target. There is the zero RTT relay attack also there. Inadequate connections, if there is no connection made by the UDP layer in between, any fault occurs that will like affect the data also breach. Okay, next up I'm gonna show you the here is the Wireshark, which I have I just captured the packets from the website YouTube I opened before 20 minutes. And here is the data we collected from that particular handshake, and here is the handshake done. Initializing the processes by the UDP underline, and source and destination are covered. Initializing, as you can see, different particular pogging like padding, crypto, and this particular flags are being used, PK1, and initializing these particular scenarios. In this you can see the data in the initial packets. In the initial packet we have the connections information. First of all, the packet length, which normally the GUIC packets are very large because they contain very full information, because they are duplicating that particular message. Also, if it drops down, it is also storing that particular these flags, different flags for that particular reason. They are fast. Also, you can also use the padding for that particular structure to emphasize the data that is being stored, and that is like a push to the data that it should be fast to that particular server. We can open different flags here, that is the frame and offset and the length of that particular data being passed to the server and received at the same time being used by the different multi-streams networks. Here is the token length and the length being specified here, and the destination. I was talking about a specific port which was fixed in that particular, which is the destination connection, not the length. This is particular that is being fixed 7A3FT. This is the if the IP changes, no matter what the IP changes, this will stay the fix, so that you if you change the password, if you change the Wi-Fi or connection with your network, this remains the same and your video works till fine till then. Fixed bit true and packet type initial 0 because it is initial packet. If we talk about the other packets, the byte will be increased and the other data may be increased, may be visible here, will be visible here. Lest initial packets include that particular crypto and ping and padding more than this particular, because that was the initial connection between that particular server and the client. Now the padding length is also less. Earlier it was 1293, now it is about 717. As you can see here, token is also 0 and the length particular that is being transferred from this particular to that. Handshake is being done through this particular step, and the length is 67. As you can see, the destination connection for this particular handshake is this one, which is being used by the, as you can see here, we can see the user datagram protocol, which is being used by this particular, as we discussed earlier. Time taken and UDP payloads. That was all I captured in this particular. We can have a great look at other payloads also the data that coming from that. The data is encrypted and we cannot see that particular data without any SSL keys and encryption settings, so that it is not visible for now. And headers are also available for that particular information, so that the IDs and the information can be fetched by the client and the server. Connection has been established. Next up, we have the last, we can talk about the QUIC scalability. How can it be improved in this particular scenario? Efficient, it is also efficient, but it can be faster by setting up the TCP and improving that particular scenarios in few cases, as we discussed earlier. If it is being used, multiplexing, if we can increase the stream channels and running it concurrently, and reading off the head of blocking, and congestion control also working, adjusting the dynamically nature of that particular protocol. Protocol support, that the multi application can be work on the single that particular server or different particular servers too. That also depends on that particular reason that the location of server is where. TCP uses that particular protocol, so it will take more time for that particular server to reach and breach the data or get the data from that particular server. If it is worldwide established, ongoing standardization we did talk about, and that is being used by many computers and applications, servers and connection established in this particular internet protocol. This was all in this video. Thanks for watching, and let me know if you have any questions